All right, learning target 2, express very large or very small numbers using scientific notation. So scientific notation is a way that we can use to kind of simplify really huge or really small numbers so that they're not as kind of annoying and you don't have to write like a billion zeros. So I want you to take a look at these two lists under scientific notation. These numbers are all written in scientific notation. Under this list, none of these numbers are written in scientific notation. So take a look at those and kind of come up with a definition kind of in your brain really quick. So pause this video really quick and kind of come up with your own quick definition or observations that you have, and then we'll write one down. Okay, so from what I can see from those two lists, one list you've got a whole number between 1 and 10, and then times 10 to the something. And then over here, I don't have anything like that. I come kind of close with some of them. But so that's the kind of definition that I'm going to write down. Okay, so you've got one part here. This is going to be a whole number between 1 and 10. Oop, 1 and 8. 1 and 10. And then I've got a times, and that last part is 10 to some power. Okay, so we've got examples like 3.4 times 10 to the fifth, 6.023 times 10 to the fifth. We've got a whole number between 1 and 10 times 10 to some sort of power. Okay, so those are our two parts to that definition. Okay. Now let's talk about this to some power. Okay, so we've got times 10, and then we have it to some exponent up here. Okay, some something up there. Now, if that exponent, if that is greater than 1, then this is a very large number. If this exponent is less than 1, in other words, if it's negative, this is a very small number. So we talked about negative exponents a little bit. If this is, say, 3 times 10 to the 30th, then that means that this is a huge number with tons and tons of zeros. If this is 3 times 10 to the negative 30th, this is a very, very tiny number that would maybe be something like 3. So if we have like 3.0 times 10 to the negative 20th, this would be a 3, and then we would move this decimal point 20 places to the left. Okay, 20 places way over here. So there would really be 20 zeros before we get to this 3. Okay, so that's how we can show really small numbers. Let's go back to our list for a second. So we're going to classify each of these things down here as either in scientific notation or not. This one we've got a whole number between 1 and 10, and we've got times 10 to the third. So this is a very large number because this exponent is greater than 1. This is a very large number, and yes, it is in scientific notation. Over here, 32 times 10 to the fifth. This is not in scientific notation. And the reason I know that is because this number here is not between 1 and 10. So if I want to change that, I have to make this between 1 and 10. So I'm going to move the decimal point to there. And now instead of times 10 to the fifth, this is going to be times 10 to the sixth. If I needed to change that to be in scientific notation, it'd be 3.2 times 10 to the sixth. The last one, this is also not in scientific notation because this is not a whole number, some whole number between 1 and 10. So in order to change that, I can move this decimal point one place to the right. So I'm multiplying by 10, which means I need to take a 10 off of here. So this is going to be 2.8 times 10 to the 10th instead of 11th, because it took me multiplying by 10 once just to get it the decimal point to there. Okay. So this example, Meredith's doing a report on stars and wants an estimate for the total number of stars in the universe. She read that astronomers estimate that there are at least 125 billion galaxies in the universe. An encyclopedia says that the Milky Way, Earth's galaxy is estimated to contain more than 100 billion stars. So estimate the total number of stars in the universe. Okay, so if we have 125 billion galaxies and each one has about 100 billion stars, we're going to multiply them together. And 125 billion, I'm going to write that in scientific notation. Instead of doing there's 100 billion totally written out. Okay, but we can save ourselves the effort of writing out all of those zeros if we move the decimal point from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So we can rewrite this in scientific notation as 1.25 times 10 to the 11th. And I have 100 billion stars, so write that 100 and if I write that in scientific notation, this is just 1 times 10 to the 11th. So I can write that as 1 times 10 to the 11th, and then I need to multiply these two together. So 1.25 times 10 to the 11th, and then times 1 times 10 to the 11th. I can first multiply these two parts together and get 1.25 times 1, which is just 1.25, times, and then I can multiply these other two parts together, my 10 to the 11ths. I can combine those together because we know powers of exponents now, or products of exponents. So 10 to the 11th times 10 to the 11th is just 10 to the 22nd, and this would be my answer. So there are approximately 1.25 times 10 to the 22nd stars in the universe. Okay. Before class, rewrite this number here in scientific notation. Rewrite this number here in scientific notation. A little hint on this one, since this is a very, very tiny number, you're going to have an exponent which is less than 1. So it's still going to be something times 10 to the something, but this exponent up here is going to be a negative number because this is a very, very tiny number. Okay?